Welcome to JD's Prep. In this problem, we want to know which one of these four equations can be used to determine the zeros of the function f of x equals 2x squared plus x minus 3. To find the zeros of a function like this one, we want to set the function equal to 0. So the first thing we would do is we would have 0 equals 2x squared plus x minus 3. The polynomial function on the right side of this equation is a quadratic polynomial of the form ax squared plus bx plus c, with our a being 2, our b being the assumed coefficient of 1 on the x, and c being negative 3. To factor a polynomial of this form, we use what is often referred to as the AC method, where we start by finding the product a times c, which in this case, a we said was 2, times c, which we said was negative 3, which will give us negative 6. Then we want to find two numbers that will multiply together to the negative 6 that we just found, and then add together to the coefficient on x, our b, which is 1. So we want two numbers that will multiply to negative 6 and add to positive 1. Now, since we want to multiply and end up with a negative number, that tells us that the signs of the two numbers we're multiplying have to be opposite. So one must be positive and one must be negative. With that in mind, we can start listing out the factors of 6. So we have 6 and 1, but one of them must be negative, so let's start by having the 6 be negative. Or we could also have 6 be positive and 1 be negative. The other pair of factors for 6 is 2 and 3, so we could have negative 2 and positive 3, or negative 3 and positive 2. These are the four possible pairs of numbers that will multiply together to give us the negative 6. We want those numbers to add together to positive 1, however. And if we start working our way through the list, negative 6 plus 1 is negative 5, so that one won't work. 6 plus negative 1 is positive 5, so that one won't work. Negative 2 plus 3 will give us positive 1. So the negative 2 and the positive 3 are the two numbers that we want. Once we find those two numbers, what we're going to do is we're going to rewrite this middle term here, the plus x, and kind of undo the combining of like terms. That would happen if you're multiplying out one of the expressions in the four equations we're choosing from. And we're going to do that by replacing the plus x with two x terms that have the coefficients of the negative 2 and the positive 3 that we just found. That's going to make our equation 0 equals 2x squared minus 2x plus 3x minus 3. And to double check and make sure that your separation here makes sense, you can always mentally or on the side combine like terms again and end up right back where we had started with the plus x. Now that we have separated our middle term, we now have a polynomial with 4 terms. And anytime you have a polynomial with 4 terms, you want to factor that by grouping. So we'll group together the first two terms and take out the greatest common factor of those two. And we'll group together the second pair of terms and take out their greatest common factor as well, with the hope that we will have the same factor left over in each half. For the first half, I can pull out a 2x from both of those terms. So I can rewrite it as 2x times what's left over when we divide each of those first two terms by 2x. For the 2x squared divided by 2x, I'll be left with just x. And minus 2x divided by 2x will leave me with minus 1. So I can rewrite those first two terms, factoring out the common factor of 2x, as 2x times x minus 1. Now when I move on to the second half, the 3x minus 3, I want to factor out a common factor from those two that will also leave me with this x minus 1 for that half. And in this case, their common factor is 3. If I factor out that common factor of 3 and divide each of those two terms by 3, 3x divided by 3 will leave me with x, and negative 3 divided by 3 will leave me with minus 1. And as I had hoped for, I got the x minus 1 in both halves. Since I have x minus 1 in both of those halves and they're being added or subtracted together, I can factor that out as well as a common factor. I do that by rewriting this as the product of what's left over after removing that factor, which from the first half I'm left with the 2x, and from the second half I'm left with the 3. So one of my factors is 2x plus 3, times that common factor that I pulled out, which is x minus 1. And again, if you follow this process in reverse, you're basically foiling the product 2x plus 3 times x minus 1, and you can do that to check and make sure that you do really end up with the 2x squared plus x minus 3. But now that we've got our factored form, we want to compare that to the 4 options that we have. And by paying very close attention to the signs for each of our terms, you'll see that the factored form in number 2 is the one that matches our solution here. So anytime you have one of those trinomials, a polynomial with 3 terms, where a, the number in front of the x squared, is not equal to 1, you'll need to use this AC method to factor it. Break that down into the factored form and match it up with one of the 4 in your solutions.